So this is module 11.1, solving quadratic equations by taking the square root. And we are, we did this little warm up because we learned this skill in module 9, okay, 9.1 to be exact. So here, if you look at this, we're gonna add 16 to both sides, right? So 2x squared equals 16, and then divide by 2 on both sides. So we get x squared equals 8. Square root both sides. Why do we square root both sides, class? Why do we square root both sides? Can someone give me the mathematical answer? Yes. To get rid of the exponent. How do we get rid of the exponent, or why do we get rid of that exponent? Why is the square root getting rid of the squared? Why do they cancel each other out? There's 2. Why? Why? Opposites. Close. What? What is it called? Reverse operations, closer than opposites. Reverse operations, inverse operations, right? Just like how addition and subtraction are inverse operations, just like how division and multiplication are inverse operations, squares and square roots are inverse operations, okay? So here, when I take the square root, don't forget the plus and the minus. Square root of 8. Am I done? Because I need to do the prime factorization, right? So 4 and 2, and then 2 and 2. And so these two guys, these two 2's come out and make 1, 2. And this 2 here does not have a partner, right? It's sad because he doesn't have a partner, so he has to stay in. Okay? That's why that 2 represents this lonely 2. Okay? Equals x. And that is my answer. Okay? Here, number 2, subtract 9 on both sides. Negative 5x squared equals negative 9. Class, here, right? My spider senses kind of go off because I know I'm going to have to square root it, correct? Because it's x squared, but it's a negative number, okay? So hold that thought. It's a little troubling, right? But yes, I could multiply it by negative 1, or I could just divide it by negative 5. Okay, just kill 2 birds with 1 stone. These 5's cancel out. Negative times a negative is a positive. Negative divided by a negative is a positive. So I have x squared on this side, right? Equals negative divided by a negative is a positive 9 over 5, right? So now I can square root both sides again. And then x would equal plus or minus, what's the square root of 9? 3. Square root of 5, I can't do anything with. So that's just the square root of 5. But remember, class, what's wrong with this answer? Yes. You cannot have a square root in the denominator, right? So how do I get rid of it? Multiply it by square root of 5 over square root of 5. Why is that? I see your faces. Why is that? It's because in my denominator, I cannot have a square root, correct? Yeah. So the first thing this square root of 5 needs is a partner, right? And I'm pointing to this because these two has a partner and it came out, right? Same thing here. Square root of 5 times square root of 5. Now this square root of 5, this black square root of 5 has a partner in the green square root of 5. So in my denominator now, I have a 5, right? That's the first reason why I multiplied it by square root of 5 over square root of 5. The second reason is, what is the value of square root of 5 over square root of 5? 1. And whenever I multiply anything by 1, it's just by itself, right? It's just the answer is whatever that number you're multiplying it by, right? So I'm not changing the value of this 3 over square root of 5. I'm just making it look different, okay? I don't want to change who you are. But a little makeup would make you look better. I'm kidding. I'm kidding. So that's 3 square root of 5, right? Plus or minus equals x. So that is my answer. Okay? But going back to this question, warm-up number 2, where we brought up this part here, right? And this is the meat and potatoes of this lesson. Is when I square root a negative number, what's my answer? It's impossible. So what is my answer? No real solutions, right? I love that. No real solutions, right? Okay. Okay. Keep that in mind as we go and do this example. No real solutions. Okay. So I'm going to do the same thing like warm-up number 1 and number 2. I'm going to subtract 16 on both sides, right? And proceed to solve for x. Okay. Divide by 4, divide by 4. Here's that negative again. But this time, it's actually negative, right? Yeah. So here in module 9, in the module that we just did, our answer would be no real solutions. Okay, and it will be done. This is my answer, and it will be done. Right? Questions on that? No, right? Because I know if I square root it, well, let's just go ahead and square root it. Then I have x is equal to plus or minus square root of negative 4. And then I can say, oh, there's no such thing as square root of a negative number. So it's no real solutions, right? But wait. In module 11, in this module, in this new module, we're going to learn something called imaginary numbers. Okay, or the imaginary number. Okay, just one number. The imaginary number is actually square root of negative 1. Okay, it's the square root of negative 1, and that representation wise is just I. Just the letter I for imaginary. Okay, so now we know that whenever I have a square root of a negative number, that's just I. All right. So here, going back to this example, right? Now that I know that, I can rewrite -4 as the square root of -1 times 4, correct? -1 times 4 is -4, right? I didn't change anything, just making it look different, right? So here, I can say this is square root of -1 times the square root of 4, right? In my rules of roots, okay? So we just learned that I equals square root of -1. So I can turn this square root of -1, this guy here, into I plus or minus equals X. So X equals plus or minus I. What is square root of 4? 2. So I'm going to make it 2I. Easy enough. Whenever you see a square root in the square, or whenever you see a negative number in the square root, just take out the negative and put an I on it. All right? Okay. Going back to this thing here. Yeah. We said that that the squared and the square root right here, when we're talking about inverse operations, are inverse operations, right? The squared and the square root, they cancel out, right? So if I wanted to cancel out this square root, I would have to square it. Yeah. This leads to a new concept. Okay, if I square this side, I would have to square this side as well. Correct? So this leads me to a new concept. Left-hand side is equal to I squared. I'm going to put it down here. Equals, well, if the squared and the square root, they cancel out, what are you left with? -1. Okay? So I squared equals -1. And then I equals square root of -1. This part here is the new idea for this lesson. Okay? And then what we're going to do with that is we're just going to practice that. Okay? We're going to practice that. All right? So let's practice that by finding the square of the imaginary number. Okay, we're going to find the square of the imaginary number. Okay? My first example is going to be 5i. So if I take the squared of this, right, literally squaring it, okay, the squared goes to both the 5 and the I. All right? It's somewhat like the distributive property. Okay? So 5 squared times I squared. What is 5 squared? 25. What is I squared? We just did it. -1. So 25 times -1 is -25. Right? Okay. I'm going to pause and talk about that inverse operation again. Okay? So we said square roots and squares are inverse operations, correct? If square roots and squares are inverse operations, hypothetically, if I take the square root of my answer, and notice that I just squared it, if I take the square root of this answer, I would have to end up with 5i, correct? Yeah. I just squared 5i to get negative 25, right? So if I square root this negative 25, then I would have to get 5i. Does that make sense? Yeah? We all understand that? So let's try that. Square root of negative 25. I know my answer is going to be equal to 5i, or I'm hoping that my answer is going to be equal to 5i. Okay? So if I have this, well, this is going to equal square root of negative 1 times 25, right? That is going to equal square root of negative 1 times square root of 25. What is square root of negative 1? Huh? What is the square root of negative 1? Huh? 1. Not 1. I. Thank you. What is the square root of 5 or 25? 5. You guys see how they're equal to each other? Yeah. So using what we just learned about I equaling square root of negative 1 and I squared being negative 1, I just showed you guys that two things I showed you. That this is correct. Yeah, when you square it. Because I just proved if you inverse it, or if you, using your words, take the opposite operation of it or reversing it, I would get back to where I started. And I forgot number 2. Okay. So that's that. Questions on that? No? Okay. The second one then, I square root of 2. If I square I square root of 2, right? Then this squared would become, or I have to distribute the squared out to the I and the square root of 2, right? There's the inverse operation again, right here, right? Square root squared. So they would cancel out and I would have 2 here. What is I squared equal to? Negative 1, right? So that equals negative 2. Okay. Our third, negative 2i. If I square negative 2i, I'm going to end up negative 2 squared times I squared. What is negative 2 squared? Huh? 4. Negative 2 times negative 2 is positive 4. I squared is negative 1. So that would be negative 4. Okay. And in the fourth and final example of this, the set of directions, 3 square root of 3, or square root of 3 over 3. I if I square this, right? This will be square root of 3 over 3 squared times I squared. Okay? Now again, this squared here goes to both the 3 square root of 3 or square root of 3 and the 3. Okay? So then if I show you guys that, it would be like that. And then I squared is? What is I squared? -1, right? -1 times this this term would just be a negative. What is the square root of 3 squared? 3. Again, these two guys would cancel out, right? Leaving you with a 3 over 3 squared is 9, which is -1 over 3. Okay? Cool? Questions? Comments or concerns? No? All right. The last little idea that I want to cover is the discriminant. What is a discriminant? Hint? Do you guys need a hint or does anyone know? Clue number 1. Okay? I play this with my son. Clue number 1. I'm thinking of an animal. That's what I play with my son. Clue number 1. He has a long neck. Yeah. Anyways, the discriminant, clue number 1, it tells me what type of solutions I would have. How many and what type of solutions I would have. No one? Clue number 2. It's a part of my quadratic formula. It's a part of, what is the quadratic formula? X equals -b plus or minus square root b squared minus 4ac all over 2a, right? That's my quadratic formula, correct? The discriminant is a part of this, and it tells me what type of solutions I have. Okay. It's b squared minus 4ac. Do you guys remember us talking about, hey, look, if this is a positive number, if b squared minus 4ac is a negative number, right? Remember module 9, where a negative square root would be 0 real solutions, right? And if b squared minus 4ac equals 0, we have a certain number of solutions and what type it is. And if b squared minus 4ac is greater than 0, what's going on? Okay. If b squared minus 4ac is less than 0, then I would have 2 imaginary solutions. if b squared minus 4ac equals 0, I would have 0. Hold on, guys. Or I would have 1 real solution. And if b squared minus 4ac is greater than 0, I would have 2 real solutions. Okay,